Welcome, everybody in the lecture hall from Zoom, from the future. Today, we are going to continue covering syntax. And after this, we will go ahead with white column stores, which is another physical layer, actually, in order to store, guess what? JSON, XML, and so on and so on. All right, so I will start, as always, asking you a question, and then we'll continue with the rest of the lecture. So we covered HDFS, remember, we finished last week. And I explained to you what a name node is, what a data node is, and what is actually stored on data nodes and what is stored on the name node. Here I'm asking you what is not stored on the name nodes. Is it the mapping from the files or the path of the files to lists of block IDs? Is it the file namespace? Are these the replicas of the blocks, so the data itself, sized 128 megabytes each, at most, or a mapping from block IDs to lists of data nodes? 3 of these 4 are stored on name nodes, but the 4th one is not. So let's take a look. So there is a majority, and most of you are saying the replicas of the blocks. Where are they stored? They have to be somewhere, right? So where are the replicas of the blocks? Maybe on Zoom you can tell me. Anybody? Where do we store the actual blocks?
On the data nodes.
On the data nodes, exactly. So the data nodes store the actual blocks, and the name node knows to reassemble the blocks into files. So that's the metadata. All right. Let me switch back. Slides. Okay. All right. Okay. So just a very quick recap on syntax. Why are we not looking at CSV? Because CSV is just perfect for relational tables, right? So why is it that we are looking at XML and JSON? This has to do with data variety. It has to do with the fact that the shape of the data can be something else than a table. And in particular, what is this? Oh, I didn't open the right set of slides. Give me just a few seconds, because of course I jumped directly to where we left last time. This one. There you go. So we saw that in the beautiful world of relational tables, the data is flat. Every row has exactly the same columns. Within one column, the values all have the same type. But in real life, if you actually dump data, for example, on data lakes, then you will see that there are extra values or extra columns on some rows. There can be missing values, a lot of them, invalid values. So you can have a string in the middle of integers, or even nestedness with tables in tables in tables in tables. This is a different data model. This is a denormalized data model. And we will see that the syntax to cover that is XML or JSON. And CSV cannot do it. CSV can only cover flat and homogeneous data models, which means relational tables. So I gave you an example to start with as an appetizer with some denormalized data. So here, why is it denormalized? Because we have a table in a table, right? And now you see below, that would be the syntax for this with JSON object. So you can see at the top level, we have 3 keys: product, price, and orders. These are the 3 top columns of that table. But you see that orders is not just an atomic value. So here we break the atomic consistency. We are not in the first normal form. And instead, we have an array. You recognize the square bracket here with 3 objects with customer John quantity 1, customer Peter quantity 2, customer Mary quantity 2, 3 objects. And you recognize these 3 objects. These are the 3 rows of the nested tables, right? And you remember, we covered that last time. The square brackets, these are arrays. It means an ordered list of whatever. In that case, it's 3 objects, but it can be whatever. And the curly braces, these are 4 objects, and the curly braces always have key value pairs. It's the key value model. With, in that case, you see every time we have keys associated with values. These are objects. So we have arrays, we have objects, and 4 more building blocks of JSON, which are the atomic values. We have strings, quoted strings, always double quotes. We have numbers, including potentially a decimal period and exponents with the E letter. We have booleans, true or false, but you don't need the quotes around that. And null, which is the absence, it denotes basically that a value is not known or unknown and so on, right? So you can put a null as a value as well. Note that in JSON, you can associate a key with null, or you can remove the key, right? This is not the same thing to have a value associated with null or to have this value being absent. This is a subtle distinction, and not all data models actually do that. All right, for whom is that clear? Like oh, I have the sun in my eyes. For whom is that clear that this JSON here is the syntax that corresponds to the table above? Yes, all of you? All right. So we looked into JSON, and I gave you the 6 building blocks, and now I'm going to continue by giving you some of the rules of what you can and cannot do with JSON. A first example here of something you cannot do is keys that are not strings. This is forbidden. Here on the top, you have a key that is an array. That's not okay, you cannot do that. And then you have an integer that's also not okay. So what's okay, and you see it with the green tick, it's 1 as a string and 2 as a string, then that's fine. These are keys, right? So the keys must be strings, but the values can be whatever. The values can be objects, arrays, null, booleans, strings, numbers, right? Can be whatever. Something else is you cannot have duplicate keys. In the same object, it's not okay to have twice the same key. Now, to be more precise, if you actually look at the specification, technically the RFC, it means request for comments. This is a repository of proposed standards. So if you look at the original RFC of JSON that explains how it works, it says you should not have duplicate key. It doesn't say you must not, it says you should not. So you might still have a few people here and there that might have duplicate keys in JSON. However, you know that's something that we tell computer scientists, you should treat warnings as errors. You should basically, if it says you should, then you should treat it as a must. So for this reason, many products that use JSON, and that includes the document stores and so on, they treat the should as a must, and they completely forbid duplicate keys. In a way, it makes sense, because if you think of this as representing a table, it means that you have 2 columns with the same name in a relational table. That's not allowed, right? It kind of makes sense to forbid the duplicate keys, right? So the second one is fine because these are 2 different keys. The first one is not, right? So again, it's technically a should, but many people treat it as a must. So you should really not do that, because you're going to be incompatible with many products if you do. So for the purpose of the course, we will just forbid it. We do not allow duplicate keys. This here is a concrete example from a real-world data set, which is called the Great Language Game. It was actually, now it stopped, but a few years ago, it was an online game where you could listen to language audio, and it would give you a choice between 4 languages, and you had to pick the language you think it is. So in that case, some Italian was played. The user was presented with the choice between Chinese, German, Italian, which is the correct answer, and English. And the person answered German, right? And that was on the 7th of November in 2018, and that was somebody in Switzerland, right? The sample is just some ID to identify this precise play. And so there is a data set that we like to use in this lecture that they released with, I think, 16 million of these. So it's a collection of 16 million objects, which always have different values. But you will see that they all have this structure, right? Turns out they all have these fields, just with different values, of course, but they all look alike. How we model that, we'll see in 2 weeks. How we treat collections of JSON objects that look alike. This is called schema validation, but we are not looking at that yet. So technically, with what we are doing today, you could have a huge mess, right? You could have a collection of millions of objects that look nothing like each other, right? So this is a concrete example from the real world, and we'll give you the address. You can even download it, and you will see it will be a text file, and there will be one JSON object like this on every line, 16 million of them. It's 2 gigabytes roughly, the uncompressed version. If it's compressed, you can actually squeeze it. Okay, now I told you 16 million one per line. This is pretty much what it looks like. So technically, this is called JSON lines, this syntax. It means you have one JSON value per line. In that case, there are 5 lines, so 5 JSON objects. And typically, the idea is that every row here corresponds to a row, every line, sorry, corresponds to a row in a relational table if you would have flat objects and so on and so on, right? So this is the case that the data is actually normalized and the JSON object is flat. So every line corresponds to a tuple in the relational table, right? JSON lines is the name of that standard with one object per line. Who is following? Right? It's early, so, and it will be worse next week when we switch to summertime. It will be even 1 hour earlier. All right, so. And then when we nest, then that's what I showed you earlier. This is what we get. This idea of having arrays of objects, like you see in orders, it's an array of objects. This is a very common pattern for modeling nested tables. But again, it doesn't have to. You could have an array of mixed stuff. You could have an array that has an integer and a string and an object, and it's just messy, right? There are no patterns. Okay, so this is JSON. So JSON is relatively simple. In fact, this is why it's growing in popularity. There's objects and arrays, which are data structures that people encounter at a lot of places when they look at data, and it has simple types like strings, numbers, booleans, and null. Now, there was a life before JSON. And it started before the whole thing with denormalized data storage. And in fact, XML is the other one that is quite popular. Now, do not fall into the trap of the fight between XML and JSON. People are fighting over it. If you want to start a troll on an internet forum, then just start asking, should I use XML or JSON? And then you will see what happens, right? Do not fall for that. These are 2 different technologies. JSON is on the rise. There are more and more technologies being developed. For specific use cases, it's actually great. So actually in this course, we'll use a lot of JSON, but do not underestimate XML. Do not underestimate XML. In academia, there's not much research anymore going in the direction of XML. It was 10 years ago, it was very trendy and database conferences were filled with XML. But in the industry, in companies, XML is extremely popular. The reason it is extremely popular is that it is a set of standards, a whole ecosystem by the World Wide Web Consortium, the same that does HTML and HTTP and so on. It is enterprise ready. If you want to have exchange data and you want to use XML, then you have a very robust set of tools for that, and even free tools. You have libraries all over the place that do that. XML schema, which we'll see in 2 weeks, along with JSON schema, is extremely powerful and enterprise ready. And this is an example from in Switzerland. So the tax offices in the cantons and they are trying to store the data, right, that you submit with the tax returns, right, every year. So for private persons and for companies, and they have an XML-based standard that they store them in. And in fact, the banks can give you a yearly report for the tax return that has all the list of everything you have and a QR code in there that the tax office can scan when you actually upload it to the website. Guess what there is in that QR code? There is actually an XML document, right? That looks a bit like this, right? So there is an XML document, and that XML document contains the actual data. And it is denormalized because a tax return is not a table, right? It's a bit more complex than that. There is a hierarchy of all the numbers that you have in there, right? So this is why this is just an example. The reports that are filed in many countries, so in the United States, for example, the public companies are required to file their balance sheets and income statements and so on in a format that is actually XML, right? More precisely XBRL, but it's a dialect of XML in terms of syntax. And we are talking about thousands of companies. In the European Union, they've had to do it now for 2 years with the European Single Electronic Format, right? This is all XML. So just to tell you, do not underestimate XML, even though it's less trendy now, apparently, because JSON is the cool syntax to use. In companies, XML is extremely popular in enterprise reading. Okay, I'm done giving you the context. Now I'm going to introduce XML. So XML can be recognized because instead of these angle brackets and curly brackets that you see in JSON, in XML, there's angle brackets, the ones that you see right here. So the smaller than, greater than signs. Some people call it a tag soup because in fact, what you are doing is tagging stuff. So for example, if you look at this one, this here is some portion of document, and we say that we tag it with foo by having an opening tag here that says that's the beginning of this zone, and that's the end of this zone with the little cross here. How do I remember it? It's like when you, in some countries, when you leave a city, then you have a crossed name that basically says you're leaving, right? So we are entering the foo zone, and then we are leaving the foo zone, right, with this little slash, right? So that's called an opening tag. This is called the closing tag, and here you can have more things in there, right? So again, this is what replaces the curly braces and angle and square brackets of JSON. We have these angle brackets. This is called an element, right? An XML element. And because people are lazy, in the case that what there is inside is completely empty, you would just have an opening tag followed by a closing tag with nothing in between. There is a shortcut for that, because you would have to write this basically if it's empty. But there is a shortcut where you just write the name of the tag, but with the slash at the end, right? That's it. It's just a shortcut. You don't have to. You can also write it that way if it's easier for you. But if you see the slash at the end, you should know that it's an empty tag. And there's only one then. There is no corresponding closing tag because it's auto-closing, right? It's both the opening and closing tag. Okay, so that's an XML element, right? We'll see that they nest. You can have elements in elements, in elements, in elements, just like you can have objects, in arrays, in objects, in JSON. Okay, that's the first one. Now let's move to the second one. That's called an attribute. An attribute is something that belongs to an opening tag of an element. For example, here we have an opening tag, A. Sorry, it's even an empty tag because there's a slash at the end, so it's both opening and closing. And here we have an attribute, at, that's associated with the value, right? This is called an attribute. In fact, in any opening tag, you can have as many attributes as you want, right? And that's just a key value model where you associate keys with values. You could compare it with a JSON object if you want, that you associate keys with values, but there is a difference, is that the values have to be atomic here. You cannot have nested stuff in the value. It has to be just a string, really. Okay, so these are attributes, and you can have more than one, of course. Here is just one, but there can be more than one. And the attributes can be either in the empty tag or in the opening tag. These are the two places they can be at. They can never be in a closing tag. Okay. Next, the third building blocks, I'm giving you one by one the components that you find in an XML file. This is just text, just like that, without any quotes, nothing, just text. In fact, XML started, was very popular, and is still today, in the publishing industry. Because in XML, you can store books, scientific papers, right? Where you just put the text in there and you tag the text. For example, you can tag a title, you can tag that this is bold, you can tag that this is italic, you can tag that this is a paragraph, and so on. So this is why you can have text just like that in XML. And that text happens to be inside an element in that case, but it can be completely mixed with everything else. So this is just text. All right. So again, the publishing industry had a strong use case for that. Who of you knows HTML? I think a few of you, right? Okay, this shouldn't surprise you because this is the same way that HTML works, right? The text of the web page is just text in there, right? HTML can be seen as a dialect of XML. More precisely, XHTML is a dialect of XML, which is one of the two flavors of HTML. So elements, attributes, text. Then we have comments that look like this. Don't ask me why. This is just historical reasons in the way that XML was itself simplified from earlier technologies. So that's just how it is, right? You have lower than, you have an exclamation mark, you have a dash dash, and then you have your comment, and then you have again a dash dash, and then the angle brackets again. So this is a comment. It's just like the slash slash things that you see in C++ or Java, or in some languages, it's with a sharp. In LaTeX, it's a %, and so on and so on, right? So this is just a comment there that you can put in XML documents. The difference with comments in other languages is that XML comments are actually visible to the parser. So whoever parses an XML document with a library, they will see the comments. And that's different from other languages where the comments are just thrown away when you parse it. Okay, so elements, attributes, text, comment. This is a text declaration. This is something you can see at the very first line of the XML document. It's basically just something that says, hey, here comes an XML document, right? That's what you put on the first line. It looks like this. And it's an opportunity to say something about the version of XML that is used. There are only two, by the way. There's 1.0 and 1.1, and there is really not a big difference between them. It's mostly due to internationalization, right? So there's very little difference. 1.0 is actually the most popular one, but you can put the version there. And the encoding UTF-8, I told you about encodings last time, could be ASCII, could be anything else, but UTF-8 is the recommending, right? So this is what you find just like that at the beginning of the document. Cannot be anywhere else, can only be on the first line. Okay, and that's it. Only these 5. That's easy, right? It's even less than JSON, right? In JSON, you have 6. Here you have 5. Elements, attributes, text, comment, and text declaration. Now, if you cook and you look at the cooking books and you look at the list of ingredients, because that's pretty much what I give you, that's the list of ingredients of XML, that's not enough to bake a cake, right? You also need the instructions of how to put it all together and mix the ingredients. So now I need to tell you how we mix these 5 ingredients here, element, attribute, text, comment, text declaration. How do we mix that into an XML document? So here you go. That's an example of well-formed documents, well-formed meaning it's correct, where you see on the first line this XML version blah, 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 that just informs you that this is an XML document encoding with UTF-8. And then what you see is an element. It's an empty element. Why? Because the slash is at the end. So it's closing and it's opening and closing, right? So it's basically just an element foo with nothing inside. This is well formed. That's totally fine. It's one of the smallest documents that you can ever have, but it's totally fine. That's a well-formed XML document. This is also fine because the declaration is optional, right? You don't have to have it if you don't want to. So you might find documents that don't have it. So the smallest XML document that you can ever have would be an empty element with just 1 letter. Here we have 3 letters, so it could be smaller, but this is pretty much it. That's the simplest ever. Okay, and it has to be an element. Now, here's another example of also well-formed document where we also have a foo element, but this time it's not empty. It's not empty because it's opening, and then we enter the foo zone, and then we see an empty bar element that is nested inside, and then we leave the foo zone / foo, right? So we have an element bar nested inside an element foo. All right? Okay, it's basically much like you enter Zurich, then you enter the ETH Zentrum, then you leave the ETH Zentrum, and then you leave Zurich, right? That's pretty much how you can see. Okay? This is forbidden. Text cannot be outside of the top level element. So text here, that's forbidden. You cannot have it here. Text must be inside an element, cannot be on its own. So here we have an element foo, then we have some text, then we have an empty element bar, and then we have some text again, and then we close the element foo, right? So this is a load. This is perfectly fine. You can actually mix, if you want, text and child elements. This is totally fine. In fact, in HTML, this is exactly what we do in a web page. Okay. So again, here we have a top-level element foo that has 3 children. So it has 3 things that are inside. It has some text, then it has another element, and then it has some text again. This is forbidden. This is forbidden because what did we do here? We put an element slash, so that's an empty element, but look at where we put it. We put it inside the opening tag. No, you can't do that. If you have an element, it must be between opening and closing tags. It cannot be inside the tags themselves. So this is not okay. You cannot do that. Okay, it has to be between the tags and not inside tags. Okay. This is also not okay. You can also not put an element inside an attribute value. That's not fine. So this is disallowed. The elements have to be between opening and closing tags. The attribute values must be strings, period. You have to have atomicity here. You cannot nest within the attributes. You can only nest between elements. Okay. So here I just put elements. Now I removed these angle brackets, and this is fine, right? So this is totally fine. Okay, now just so you know, because it's not that it's that important, but you will not be surprised if you see that. In some XML documents, you might see an additional line on the second line. So right below this XML declaration, that's called the doc type declaration, document type. So it's basically doc type, and what's after that is just the name of the top level element. So in that case, it's document. You see there's an elements document and closing documents. So you say doc type elements. Who already saw doc type HTML? Some of you, if you open. So this is the same thing. In an HTML document, you will see doc type HTML, and then you have your HTML tag. I don't even know why I'm telling you that, pretty much just so you're not surprised when you see it, because this is basically a remnant of an older technology called DTD, but we are not even covering it, because in 2 weeks, we'll cover XML schema and JSON schema, which are more modern ways of doing the same. Right, so consider it a remnant of some older technologies. Okay, so now I've summarized what you can and cannot do in an XML document. So at the top level, you must have exactly one element. That's the top level, exactly once. You cannot have text at the top level. You cannot have attributes at the top level. By attribute, I mean that would not be in a tag, right? You cannot have an attribute just like that. Between tags, you can have other tags, so other elements, and you can have text, and you can mix that freely, but you cannot have attributes between tags, right? It's inside the opening element tag that you can have an attribute, right? And when I say opening element tag, it includes the empty element tag as well, which is auto-closing. Okay, so this is what appears where, and these are the basic rules for saying whether an XML document is or is not well-formed. So now, just like JSON, I'm giving you a few indications that you are not allowed to have twice the same attribute name. That's pretty much the same as in JSON objects, right? So the first line is not well-formed, right? You cannot have twice the attribute foo in the same tag. If it's different tags, that would be fine, but not in the same tag. Foo and bar, here we are good. We have 2 attributes that have the same name. Next, you cannot do that. What do I mean with that? What's going on here? On the top, the one that is marked with a cross. Yes? Maybe we can throw maybe 2 hops, 1 hop. Ah, almost. It's okay.
Two brackets like are enclosed in each other.
Exactly. Yeah, it's basically swapped.
Yeah,
right. Exactly. So you're basically closing A before closing B, but that's not fine. It's as if you would enter Zurich, enter ETH Centrum, then leave Zurich, and then leave ETH Centrum. You can't, right? You have to leave ETH Centrum first before you leave Zurich. That's the same here. So you're correct. You have to close A after you close B, right? So it's another name that computer scientists give that sort of things is well-parenthesized expression, right? So you have to basically do it correctly. So in other words, you have element A and element B must be open and closed inside element A, right? You cannot entangle things. Entanglement is not allowed here. Okay. Now, what do we do if we want to have characters that would be smaller than? That happens, for example, in HTML with JavaScript. If you have JavaScript code in there and then you want to write smaller than, then you have a problem. Because the smaller than is also the angle brackets, and that would indicate the start of a new element. That is going to totally confuse the parser. So you can't do that. And instead, you need to escape that character. Escaping is the same thing you do with backslashes in JSON or in other languages. But instead of a backslash, in XML, we don't use backslashes. We use the ampersand. Ampersand LT, LT for lower than, and then a semicolon, right? These are also remnants from older times, the reason it looks like that. Good news, there's only 5. So that makes it easy to remember. There is lower than, there is GT for greater than, there is apos for apostrophe, quotes for the double quotes. These are for attributes, if you want to escape characters in attributes. And then, of course, you need to escape the ampersand itself, right? Just like you escape a backslash with a double backslash, right? All right. Quick story. Why is ampersand called ampersand? Because in the good old times, the English alphabet had more than 26 letters. It has more letters. Some of them are still today present in Icelandic language. And one of these letters was this thing here, what we call the ampersand, right? And where was it in the alphabet? It was at the end of the alphabet, right? We'd say A, B, C, blah, 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 Z. Then came the ampersand. Now, it wasn't pronounced ampersand back then. It was just pronounced end, right? Because that's technically used as an end sign. To whenever you have the word end, you can replace it with this symbol. But imagine reciting that at school, right? Say A, B, C, blah, 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 W, X, Y, Z, end. That sounds strange. So the teachers, they thought, okay, how do we teach that to kids? Let's find something more elegant. So they basically did it like, okay, A, B, C, blah, 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 W, X, Y, Z, and per se, end. Per se means all by itself. End, per se, end. And so they went on reciting the alphabet like that, and of course, quicker and quicker and quicker, because then you're in automatic mode when you recite the alphabet, and then ending with W, X, Y, Z, ampersand. And ampersand compacted to ampersand, and ampersand became how it's called, right? So if you find textbooks from the 19th century, you will still find these alphabets that have this symbol at the end, right? So that's just for the piece of general knowledge that I squeezed in here for the ampersand. Hey, who knew that? Okay. Wow, so I taught you something. All right, so something else that's forbidden. You cannot have quotes within quotes, right? That would be a nightmare for the parser. So if you have a double quote in an attribute that is double quoted, then you have to escape that inside quote. And the way you do it is what I've just showed you here, the quote one, right? So you just put quotes around it. You also have to be careful with this opening angle brackets, because again, that will confuse the parser, right? So you could argue, okay, yes, but there's quotes, so we would know that it's not actually starting a tag, but this is too complex. It's too complicated. So it's just easier to forbid it. So we just forbid it. You cannot have this lower than sign, and you have to escape it as LT. The greater than sign, the other one, you're fine. You don't have to escape it, right? You can if you think that it's nicer, but you only really need to escape the first one. Okay, so here's the summary of what you must escape. In text, you cannot have a lower than and an ampersand. Forbidden, you must escape them. In a double quoted attribute, you cannot have either the lower than and the ampersand, but you also cannot have the double quotes. Now, and actually didn't tell you about it yet, the attributes can also be single quoted. Just means you use apostrophes instead of the double quotes, right? But in that case, it's obvious that you can totally have a quote inside, but then you cannot have a single quote, right? So in the case of single quoted attributes values, you cannot have lower than an ampersand, and you cannot have a single quote. But it's totally fine to have unescaped double quotes in single quoted attributes, and it's totally fine to have unescaped single quotes in double quoted attribute. No, I said twice the same thing. And it's totally fine to have an unescaped double quote in a single quoted attributes. All right. And I put an example at the top of an XML document that is well formed, where I put every time the 5 characters, but I only escaped those that I had to escape. So you see that I have an unescaped single quote and an unescaped greater than in the first attribute. I have an unescaped double quote and an unescaped greater than in the second attribute. And in the text, I have an unescaped greater than, and I have an escaped single and double quotes. And that's fine. And the rest I have to escape. For whom is that clear? Okay, so these are just the 5, and there's really just these 5. So just learn them by heart and you're good. You should know that in HTML, there's more than 5. So if you look at HTML document, you'll have more, like NBSP for spaces and so on. But here, it's only these 5. You don't need to worry about anything else. You will never see anything else in XML. Okay. Here's another thing that you cannot do. You cannot start the name of a tag, the name of an element with a digit, but that's just like variables in programming languages, right? You cannot have in the name the lower than sign, and something else, you are not allowed to start your element names with XML. That's forbidden. In fact, it's reserved. The reason is that only the W3C is allowed to define its tags that start with XML. So consider it reserved. You will not get an error if you do it, because you don't know the future, right? They might define some in the future. But you as a user with no affiliation to W3C are not allowed to create tags that start with XML in any case, uppercase, lowercase, any mix. However, a tag that contains digits, not as the first, is fine, and starting with an underscore is fine as well. That's also like variables in Java and in C, you can also start with an underscore. Okay, so just to give you a feeling of what you can and cannot do. And now I put as a reference, so I'm not going to talk more about that. This is just the reference of what is allowed anywhere in a name that you see in white over green. So basically all the letters of the alphabet and underscore you can start with. In blue, these are the ones you can have, but not at the start. So it's basically the digits plus the dash, the period, and the colon, and the rest is disallowed, black on a red background, right? Okay. And finally, just like in JSON, it's totally fine to pretty print the documents. What do I mean with pretty print? I mean that you put things organized on multiple lines and you put tabulations in order to nicely align things. That's called pretty printing. And it's totally fine to do that. It's totally useless for the computer because the computer will not care about the difference, but you as a human might actually find it pleasant to look at XML this way, right? So it's quite a common thing to do to pretty print the XML documents, and that's totally fine. Okay, who is following? Okay, so now you know JSON, you know XML, and we'll see they are very much alike. They can both store data sets, as we will see. Okay. Now, I'm going to teach you something that exists in XML, but that does not exist yet in JSON. It's a very complicated story. There is a debate over that. Some people argue, well, there's a reason why it doesn't exist in JSON, is that in JSON, we like simple things and namespaces are too complicated, right? But the thing is, namespaces are actually useful. And I will try to give you a motivation for that. So it might be that one day they actually get reintroduced in JSON as well, but we'll do it in XML. So namespaces are an extension of XML that is now fully used by everybody. The goal of namespaces is to tidy things up a little bit, right? So we're in Switzerland, that shouldn't surprise you. So we just want to keep things tidy in the way that the XML documents are organized. So how do you keep things tidy at home? Well, you go to some Swedish shop and then you buy furniture or boxes and then you put things in boxes, right? So we like to do the same things with elements in XML. So imagine that you have two data sets from real life and they both use some XML elements in different ways. However, they might use the same element names, but for different things. For example, the data set on the left might be about computer networks. And in computer networks, you can have clients, you can have servers. This is just the terminology used in computer networks. So you might have an element in that data set on the left that is called clients, meaning a computer client. And on the right, you could have a data set that is the customer database of a company, right? So the list of customers. And another synonym for customer is clients. You might have a client. But then, of course, you don't mean the same thing as in a computer network. You mean actually a person, an actual person. So the problem you have, if you start querying these two data sets together, and you might want to join them or whatever, then you have the problem that you're going to have to live with these two elements that are all over the place that don't mean the same thing. This is actually problematic. So we have to organize them in a way that we can distinguish them, right? So we could put colors. We could say, okay, there's the blue client and there's the green client, right? We could do it that way. But instead, we use namespaces. How do we do it with humans? Well, we all have names, right? And we have first names, but the first names, they can repeat. There's a lot of people who are called Peter. There are a lot of people who are called Mary, and so on, right? So how do we disambiguate? How do you know which Peter or which Mary you mean? With a family name in many countries, not all, but many countries. So we have the introduction of family names or patronyms in some other countries. It's just an additional piece that disambiguates the name with more information, right? So we are going to do the same thing in XML. We are going to disambiguate the element names by adding something that's known as a namespace, right? Now it's a W3C standard. And at W3C, that's the web consortium. So we like to, so the W3C likes to reuse its own technologies. So it was very tempting to just reuse URIs, the same URIs we saw in REST APIs a while ago. So we just say, okay, that's a URI that we use for namespaces. But again, it's not a URI you're going to put in a browser and expect a web page to appear. It has nothing to do with that. You will not put that in your browser. It's just some name that happens to start with HTTP that basically is the family name of the elements. Now, think of it. How do we do it? Let's say in Java. How do we organize the classes in Java in order to avoid that two classes have the same name? Does anybody know Java? How do we group classes? Maybe on Zoom? So we group them in packages, right? So we put the Java classes, when you write a Java program, you put them in packages. And the packages, there is a convention, you don't have to follow it, but there is a convention that people use that they start the package names with a domain that they own. For example, at ETH, when we have student projects, it's quite common that we call our Java packages ch.ethz.inf, if it's the computer science department, .math, if it's the mathematics department, .whatever, right? So we basically reuse something that has to do with the domains we own. Why do we do that? Well, if everybody does that, then you cannot collide, right? Because you don't have two people who have the same domain. So if people actually agree to use the domains they own in order to name their packages, then you avoid collisions. This is partly the reason why we use URIs here, is that if everybody creates their namespaces with a domain that they own, then they know that nobody else will, because it's their domain. It's not enforced. Actually, I could go ahead and create a namespace that starts with google.com and nobody would tell anything, right? But you just don't do it because it's the convention, right? You use the domains that you own. Is there sun on the screen? Maybe I need to close a little bit because the sun is moving, of course. And maybe I need to close here. I open here a little bit, maybe to have a bit of light. It's fine. Oh, let me stop it. Now it's okay. Okay, very good. So now you have the sun. Okay. So again, the local name is like the first name or the name of a Java class or a Python class or whatever. And the namespace is like my family name or the name of a Java package or in C++, we also have them. Or in Python, we have them too. In Python, we also have packages, right? When you import in PyPy, for example, the pip install and so on. Who knows Python? So you already, oh, I should have used Python. Why did I use Java? Of course, Python is more popular today. Okay, so you have these pip dependencies, right? That you can go to a website and have all of these packages. It's the same. So these are like namespaces every time, and within a Python package, then you have plenty of functions in there, right? So the name of the function would be the name of the local name here, and the name of the package would be the namespace, right? For whom does that make sense? All right, very good. So what I'm saying here is that namespaces are not specific to XML. You have them all over the place to make sure that you disambiguate things that would otherwise have the same name. Okay, so now that we have established that we are adding a namespace to the element names, and that we are using URIs just because we already have them and they have a domain inside, we could go ahead and say, okay, now let's rewrite our documents. Oh, I wanted to show you an example here. I forgot I had this slide. This namespace here actually exists. You can see that it has W3.org, so it's an official standard of W3C, which is called MathML, like mathematics. And this is a set of elements for writing mathematical equations. And you can also use it on HTML pages. EQ here is an equality symbol, and this EQ lives in the MathML namespace, right? So that's a concrete example, a real-world example of namespace. Now, is it me or? Oh, we should have a break. I'm talking a lot. I'm talking too much. Okay, so we'll take a 15 minutes break. Then I'll show you how the namespaces look like. So since it's 2 past, we'll start again at 17 past 9, right? You deserve the break.